Hello everyone, my name is Sunny Ravel, and today we're going to be talking about the second part of the FBLA Data Science and AI curriculum, which is Probabilities and Statistics. Now this section is going to be worth 15 points, which means around 15 questions will show up on the test. So let's just get right into it, but before I do start, I wanted you guys to let me know in the comments when your state leadership conference is, so I could plan my videos accordingly and help you guys the most I can. So let's just jump right into this video. Alright, so the first portion is being able to calculate the mean, median, mode, and range of a data set. So let's do a practice problem together about this. So this is our data set here. We have these values, and let's start with the mean. In order to find the mean, the formula is to add up all of these values and then divide by the number of values in the set. So that means the mean, in statistics we refer to it as x bar, and we'd say 12 plus 15 plus 12 plus 20 plus 22 plus 12 plus 28 plus 19, and then let's count how many values are in it. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 values, and that would be the mean. And then for the median, essentially we need to be able to order the data from the lowest value to the highest value. So let's start by doing that. So we have 12s as our lowest value, and I think we have 3 of them. So that's 12, 12, 12. And then we also have a 15, so I'll put that. And then we have, so that's 15, 15. After that there's a 20, or 19. Then there's a 20. Then I think there's a 22 and a 28. Let's see if this is also 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Okay, great. So that's 8 values. Now, for the median, we need to find the center of these values. So that would be, since this is 8 values, we'd count this way. 1, 2, 3, 4. And then 1, 2, 3, 4. These two are both the center points in the data set. So what we will do here is we just add these values up. So it would be 15 plus 19 and divide by 2, which gives us the median. So median is equal to that. And remember that for median, we need an ordered data set from least to greatest, and we simply find the centered point. If the data set given is an odd data set, then you'll be able to easily look at which number is the center. But if it's even, you're going to have to take the two central numbers, add them up, and divide by 2. Now for the mode of the data set, the mode is pretty much the most frequent number in the list. So as we can see, when we order them, we have 1, 2, and 3 12s, right? So that is the most common number in the list. So our mode is going to be 12. Remember, mode is the most frequent number in the list. And now, range of a data set. So for range, it will be the maximum value minus the minimum value. So, what is the maximum value in this data set? Once we ordered the list, we found it to be 28, and we found the minimum to be 12. So it would be 28 minus 12, which is equal to 16. What if you get graphical data instead of the numerical data we were looking at? So for this, in most of these questions, you'll likely be asked to describe the distribution of it. And it's going to be multiple choice, so it should be relatively easy. But there is a couple of things I will note about a histogram. This right here is a histogram. And with this, we can basically tell how frequent the values are for each height or each range of heights. So in most of these questions, we are asked to determine the shape of the data. And let me quickly just go over that. When we're asked for the shape of the data, we're thinking about how it's distributed. So, for example, we want to analyze the mode. And by that I mean how many peaks does it have? There's only one highest frequency, right? So that means it will be unimodal. And this means one maximum frequency. And this is pretty much most of what you need to know. They might ask you stuff like what frequency of trees are between 65 to 70 inches. In this case, we will look at this bar right here and see what is the frequency. It looks to be about 3, so that's our answer, 3. And that's pretty much the majority of the questions they'll ask if you ever get a histogram. Alright, now let's talk about measures of statistical variance. These metrics really describe how clustered or spread out the data is relative to your mean. And let's first discuss each measure and definition. So for variance, this is the average of the squared differences from the mean. So you don't need to know more than just the definition, but make sure you keep this in mind on the test because it may specifically ask for the definition. If they ever asked you to calculate, it would take quite a while, so really make sure that you're familiar with the definition instead. So the characteristic about this and what you really need to pick up from this is that if the variance is high, the spread is high. This means that the data points are more spread apart. And this is because the units are squared. So for standard deviation, you might have heard that before. It is the square root of the variance. And statisticians use this a lot in order to determine the spread of data. And it uses the same units as the original data itself, and it's most common. So now let's talk about covariance. Covariance measures how two variables change together. And the characteristic about this is if it's positive, that means that they have a direct relationship or they move together. And if it's negative, that means it's inverse. Let me give an example to make yourself more familiar about covariance. Let's say that you have two metrics, height and weight, and when you think about it, someone who's taller usually has greater weight than someone shorter, right? So that would imply a positive covariance because those two metrics move together. Like, for example, the higher the weight, the higher the height. Let's now talk about the Gaussian/normal distribution. So this is also commonly known as the bell curve, and it's fundamental to statistical inference. So let's talk about its characteristics. As you can see, it's perfectly symmetric on the left and right. This means that both the left side is the same as the right side. So it's perfectly symmetric. And one thing you really need to know about this is that the mean and the median and the mode are all at the center. So this area right here is exactly where the mean, median, and mode lie. And this is the importance of this curve is it describes so many natural phenomenon. So if you think about it, height, like natural height of humans, that's normal. The IQ, it's a normal curve. And measurement errors, they're also normal curve. So if I were to, for example, draw the distribution of maybe an IQ of maybe 2,000, 3,000 people, it would look something like this if there was no bias involved. Alright, now let's talk about expected value. So expected value is the predicted long-term average outcome of a random variable over many trials. Let me quickly write that in. So expected value, if it would type, is the predicted long-term average outcome of a random variable over many trials. And the formula for this, which we don't really need to worry about that much because I'll explain it in way more simple terms, is E of x equals the sum of x times P of x. Now we don't necessarily need to fully analyze this formula because I'll show you using an example. Let's say that we have a fair six-sided dice. Fair six-sided die. And we need to find the expected value of it. So the way we do this is we would say that if rolling a 1 is 1 point, rolling a 2 is 2 points, rolling a 3 is 3 points, and so on until you get to 6, right? And the probability of each roll, like let's say you rolled a 1, the probability of that is 1 out of 6. If you rolled a 3, the probability of that would be 1 out of 6 too, because there's 6 sides in a die. So it would be 1 times 1 over 6. So that's if you got the 1. Add that to the probability if you got the 2. And then continue. 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. So as you can see, we're just taking the value of the outcome, multiplying it by the probability, and then adding all of those outcomes together to get the expected value. Let's do another problem on expected value. You're playing a game where you roll a single fair six-sided die. The rules for the payouts are as follows. If you roll a 6, you win $10. If you roll a 4 or 5, you win $5. If you roll a 1, 2, or 3, you lose $8. Try to pause this video and see if you can solve this on your own. Alright, let's solve this together. So here, we would look at the scenarios and the values, and we'll make a table. So let's say this is the scenario, this is the value, and this is the probability. So first scenario is you roll a 6. So I'm just going to write roll 6. And you win $10. So the winning would be 10. And the probability of rolling a 6 is 1 out of 6. Now, what if you roll a 4 or a 5? We'd write that in the scenario. The probability of rolling a 4 out of 5 would be 1/6 plus 1/6, since it's two separate sides, which gives 2 over 6. Now, the value that you would win is $5. Now, the scenario is if you roll a 1, 2, or 3. Here, there are 3 sides, so it would be 1/6 plus 1/6 plus 1/6, which is 3/6. And the value would be -8 since you're losing money instead of gaining money. Now let's use the expected value formula to solve for it. So we would do the value times the probability, and then repeat that with the second scenario, so 5 times 2 over 6, and then do it with the third scenario, which would be -8 times 3 over 6, and that will give us our expected value. Let's move on. Now let's talk about the final part, which is types of variables. So for this part, there's going to be 2 types of variables here that you'll need to know. Discrete, and there's going to be continuous. Now, discrete variables are values that are countable and finite. And there are gaps between the values. Let's talk about an example. Let's say we have the number of goals in a soccer game. you cannot have any values like, let's say there's 1.5. You can't have 1.5 goals. You can't have 3.3 goals or anything like that. But there you can have 1 goal, 2 goals, 3 goals, but there is no space in between. So these are countable numbers because I can count 1, 2, 3, and they're finite because let's say we can't just have infinite goals in a soccer match. Logically, that's not possible. Now let's talk about continuous values. So continuous variables are values that can take any point within a range. So they are any point in a range, and they are measured. So examples for this would be stuff like temperature, because if you got a very, very accurate thermometer, technically you could get maybe accuracy up to 4 or 5 decimal points, and it could keep going. So temperature is one of them. Temperature. And then precise weight. You could be like, for example, 100.1113 pounds or something like that as an example. Time, because we can get into milliseconds, stuff like that, as well as distance. And that's all you need to know for the probability and statistics part. And if you would like, I'm going to post another video where I go through a practice test with 15 questions just all over what we've reviewed. Thank you all for watching. I really hope this video helped you out a little bit. And if you do need any extra help, always feel free to let me know down in the comments description. And if you appreciate what I've been doing, I would really appreciate if you'd be able to subscribe to the channel. Thank you guys for watching, and I'll see you in the next one.